Hello everyone, my name is Ishika Garg and in this video we will be discussing the differences between multiprogramming, multitasking, multithreading and multiprocessing. So let's see the flow of video. Firstly, we will introduce the topic, then we will understand what is multiprogramming, multiprocessing, multitasking and multithreading. At the end, we will compare these processes and see the differences between them. When we approach operating system concepts, there might be several confusing terms that may look similar but in fact refer to different concepts. In this video, I will try to clarify four of such terms which often cause perplexity. Those are multiprogramming, multiprocessing, multitasking, and multithreading. In modern computing system, there are usually several concurrent application processes which compete for few resources, like for instance the CPU. As we have already introduced, the operating system, amongst other duties, is responsible for the effective and efficient allocation of those resources. Generally, the OS module which handles resource allocation is called scheduler. On the basis of the type of operating system to be realized, different scheduling policies may be implemented. So let's understand what is multiprogramming. In a multiprogramming system, there are one or more programs loaded in main memory which are ready to execute. Only one program at a time is able to get the CPU for executing its instructions. That is, there is at most one process running on the system, while all the others are waiting their turn. The main idea of multiprogramming is to maximize the use of CPU time. Indeed, suppose the currently running process is performing an IO task, which by definition does not need the CPU to be accomplished. Then the OS may interrupt that process and give the control to the one of the other in main memory programs that are ready to execute. That is process context switching. In this way, no CPU time is wasted by the system waiting for the IO task to be completed, and the running process keeps executing until either it voluntarily releases the CPU or when it blocks for an IO operation. Therefore, the ultimate goal of multiprogramming is to keep the CPU busy as long as there are processes ready to execute. Here you can see a schematic view of multiprogramming. Also, for such a system to function properly, the operating system must be able to load multiple programs into separate areas of the main memory and provide the required protection to avoid the chance of one process being modified by another one. Other problems that need to be addressed when having multiple programs in memory is fragmentation as programs enter or leave the main memory. Another issue that needs to be handled as well as is that large programs may not fit at once in memory, which can be solved by using pagination and virtual memory. Let's understand what is multiprocessing. Multiprocessing sometimes may refer to executing multiple processes or programs at the same time. This might be misleading because we have already introduced the term multiprogramming to describe that before. In fact, multiprocessing refers to the hardware, that is the CPU units, rather than the software, that is running processes. If the underlying hardware provides more than one processor, then that is multiprocessing. Several variations on the basic scheme exist. Example, multiple cores on one die, or multiple dies in one package, or multiple packages in one system. Main advantage of multiprocessor system is to get more work done in a shorter period of time. And also the reliability is increased because if one processor gets shut down, another processor is there to execute the processes. Here you can see how a multiprocessor system works. Anyway, a system can be both multi-programmed by having multiple programs running at the same time and multiprocessing by having more than one physical processor. Now let's understand multitasking. Multitasking has the same meaning of multiprogramming. but in a more general sense, as it refers to having multiple programs, processes, tasks, or threads running at the same time. This term is used in modern operating systems when multiple tasks share a common processing resource. Example, CPU and memory. At any time, the CPU is executing one task only, while other tasks wait for their turn. The illusion of parallelism is achieved when the CPU is reassigned to another task, that is, process or thread context switching. There are subtle differences between multitasking and multiprogramming. A task in a multitasking operating system is not a whole application program, but it can also refer to a thread of execution when one process is divided into subtasks. Each smaller task does not hijack the CPU until it finishes, like in the older multiprogramming, but rather a fair share amount of the CPU time called quantum. Here you can see how a multitasking processor works. Just to make it easy to remember, both multiprogramming and multitasking operating systems are time-sharing systems. However, while in multiprogramming, one program as a whole keeps running until it blocks. While in multitasking, time sharing is best manifested because each running process takes only a fair quantum of the CPU time. Up to now, we have talked about multiprogramming as a way to allow multiple programs being resident in main memory and running at the same time. Then, multitasking refers to multiple tasks running simultaneously by sharing the CPU time. Finally, multiprocessing describes systems having multiple CPUs. So, where does multithreading come in? Multithreading is an execution model that allows a single process to have multiple code segments, that is, threads, run concurrently within the context of that process. You can think of threads as child processes that share the parent process resources but execute independently. Multiple threads of a single process can share the CPU in a single CPU system or run in parallel in a multiprocessing system. This is how multi-threading programming works. Well, consider for instance a GUI application where the user can issue a command that requires long time to finish. Unless you design this command to be run in a separate execution thread, you will not be able to interact with the main application GUI because it is going to be unresponsive while the calculation is taking place. As we have understood about multiprogramming, multitasking, multithreading, and multiprocessing individually, we can compare them on the basis of following table. By definition, multiprogramming means running multiple programs on a single CPU. Multitasking means running multiple tasks on a single CPU, while multithreading means running multiple threads within a single task, and multiprocessing means running multiple processes on multiple CPUs. On the basis of resource sharing, in multiprogramming, resources are shared among programs. In multitasking, resources are shared among tasks, while in multithreading, resources are shared among threads. And in multiprocessing, each process has its own set of resources. On the basis of scheduling, we can say multiprogramming uses round robin or priority based scheduling to allocate the CPU time to programs. Multitasking uses priority based or time slicing scheduling to allocate CPU time to tasks. Multithreading uses priority based or time slicing scheduling to allocate CPU time to threads. In multiprocessing, each process can have its own scheduling algorithm. On the basis of memory management, we can describe multiprogramming as each program has its own memory space. In multitasking, each task has its own memory space. In multithreading, threads share memory space within a task, while in multiprocessing, each process has its own memory space. I hope I was able to make you understand the topic fully. Thank you for listening patiently till now.